I would like to, has everyone looked at the homework? I want to discuss it with you just so that you are all on the same page. Some of you may do this with their eyes closed. Some of you need one eye open. Some of you may need both eyes open, and some of you may need a second pair of eyes. And I also want to practically wrap up the statistical inference business that we've done and go to model building. So I assume that all of you, because I asked you to, have your MATLAB installed. And MATLAB and Zoom work very poorly together in this full screen rendition. So we're going to have to be patient on that. Can I ask to read the first homework problem?
First problem says, illustrate computationally that successive convolutions of uniform distributions tend to Gaussian behavior in the manner described above.
So I think the very best thing that you need to do is to immediately open an editor, MATLAB's editor, and I'll just call my thing GEO422 homework 01. Your pane splits and you have created a script, okay? This is a script. I do want you all to know that I never anymore write scripts. I only ever write functions. I want to distinguish that. And hopefully later we will get to writing functions. What is the difference between a script and a function? A script is just a list of instructions. A function is something that takes input and produces output. A function is something that keeps everything that is happening on the inside, and that unless you ask for it, doesn't return any output. The reason to write only functions is because scripts are sort of like in their running, living, open environment of your prompt, and it allows you to be a worse programmer, because functions don't allow you to be a worse programmer because you don't explicitly define what you're going to put in and what you're going to do with it and what you want out. You're just not going to have it. Moreover, it's hard to see unless you ask for it, which means you're sort of more forced into it. Here, let's begin with a script, and then I would think we should probably turn it into a function. Will I be generating any random numbers for this first exercise? And if so, what functions would I use?
Yeah, we will be generating random numbers, uniformly distributed random numbers. I use the rand_i function.
Okay, let me be respectful and say new. Now we don't need this yet. So I'm glad I can clarify this. Right here and right now, for this first and this second exercise, we're actually not needing to generate any random numbers because we are just going to work with the shape of the functions. So I'll just say, look, PDF1, what's the simplest way by which I can make a PDF? It's not going to be final or beautiful to begin with, right? I'm just going to say, let me just make this 0, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0. That certainly, when I execute it on the right and I plot it, will generate a PDF-like function that is 0 until a point and then 1 from a certain point. Okay, despite my moniker. Why is this particular thing not a PDF?
When you integrate it, it has to equal 1, the total
Yes.
probability.
Yes, okay, so don't forget that has to be normalized. Unless I normalize, it's not a PDF. So we will be needing to normalize. So it's not a PDF yet. I'm going to make the very same one. Why not?
Frederick.
Yeah.
I think it can be, right? Because now you know several discrete numbers, which is the value of some PDF, for example, but you don't know the location of X. which means
You are right in the fact that I have not specified an x-axis. So in fact, there's no way I could properly normalize without assigning an x. And
Yeah,
then
so-
you are right that I could pick an x so that I am right all the time, because I could say, haha, this implies that x is this much, because when I do integrate against x, it does end up in 1. I'm just introducing this notice that whatever we do, we will be needing to calculate moments. Right now, I'm just giving you some function values to illustrate some shapes, but I'm stressing the point where the question started with, we're not dealing with random numbers here in this exercise. We're just dealing with the shape of functions. So this is going to be the distribution of the sum random variables from those two PDFs, which are not quite PDFs. I'll just call it PDFF. I don't want to call it PDF. I'm sure that's already a function. And I'm going to say that's PDF1 convolved with PDF2. And so now I'm going to hold on. I'm going to plot PDFF. And you are seeing right away what I wanted to illustrate. First of all, you do convolution of two boxcars, you get a triangle. That didn't quite fully work it out, but I told you that's what we get. I gave you the result. I also pointed to the reading because that's where they worked it out. It just takes 10 minutes to walk through it. So this triangular function, which itself isn't a PDF unless I normalize now, they certainly can't both be PDFs because they clearly don't share the same x-axis, but the shape is there. So if I wanted to write a little for loop from 1 to 10, and I wanted to begin with this one, and then add another one in, and another one in, and another one in, then I'm going to clear, and then now plot the result. You've seen that I've generated a function that, at least mentally, to you looks like a Gaussian. I mean, we haven't shown anything yet, but it's gotten real smooth. It's of course gotten huge because I haven't normalized anything, neither going in nor coming out. I will illustrate by saying, let's just go from 3 times. Here is F. If I now hold on and I convolve this once more, they're identical, so 1 or 2 doesn't matter. And I form that one. You see how very rapidly it smooths out, but what are you noticing other than that the areas are clearly growing and so I still need to normalize? You're noticing that, of course, the convolution by its definition of, 2 sets of numbers, 1, 2, 3, 5, 6, 7, is a vector that is longer than the individual inputs. In my physical analogy, if you touch the screen one last time and you wait for the response, then, well, you add that bit to it, right? So these things grow off the x-axis and they grow onto the y-axis in a manner that is completely non-constrained. And we are in this business here, we need to be constraining this. How about I turn this into a function right now? So if you've never written a function, this is your first function. It doesn't have to have any output, but it has to have input. Well, it doesn't actually have to have input if you're just making things up on the inside, but that'd be a little silly. So I'm going to say, let's just do a function of an input. N is the number of convolutions. And that'd be my first and only input. And let my index go from 1 to n. Or really, I should be saying it's from 1 to n minus 1, if I want to be truthful. And I know, let's say half of you have programmed in MATLAB. I'm sure you can always improve one of the things to improve is to take every piece of code that you ever write seriously. You're going to use it again. So you put your name on it, you put the date on it, you put at least the help, and I'm not finished, right? I'm just typing. This function is going to be called GEO422 HW01. And I typically, and I think this is good practice, do what MATLAB does, which is I never give functions a capital ever. They're always all lowercase, such that when on the second line I type the function name in capitals, right after the function definition, then if you say help GEO422 homework 1, you get your own help back, okay? If you interrupt the sequence of percentage signs, you only get a little bit of help. That's not good enough. So everything that's in a contiguous block of percentage signs is what you get. And these days, because I'm running various MATLAB versions, I also use version, and I'll say tested on. So with your name on it, you can share it as widely as possible, because the unspoken rule of coding is that you can steal anything with attribution. So if you get my function and you add as much as a period or a comma to it, you write your name on it and it leads its own life. And that's free software. Even though MATLAB is a paid for thing, that doesn't mean you can't give away your code. In fact, it's proper practice. So let me write the world's simplest function and end with a plot. Okay. And then I'll just say plot the result. And I'll just plot PDFF. So now, if I wanted to write myself a little script, but really it's good enough for me to do it on the command line. First of all, I could call GEO422, it's already too complicated, with 1. Where is it not plotting? There it is, it's slow on for some reason, okay? So if I do 2, if I do 23, you know, you name it, it's there. If you want to begin making a decent figure that actually makes the point, you could use subplots. Subplot, let me just show, you know, 2, 2, 1. This is another MATLAB function that panels your figure. So I could do subplot 2, 2, 1 and then illustrate this with, well, I'm going to begin with 1. Then I could subplot 2, 2, 2, 2, 2, 2, 3, 4, 4. Okay. In fact, as soon as I've given myself some reasonable example, I will right away write it into my function header. And I'll just basically copy that. But here too, I'd go for index is 1 to 4. I'll just make it short here. I'll say 2 to index. Index end. So hard to keep it all on the screen here, but CLC clears my terminal, clear all my variables in case I had any, which I don't. CLF clear the figure, help GEO422 H01, tells me what I need to know, including an example that I can just run. And then I get that. So that's most all the MATLAB you need to know, in the sense of you can give this thing instructions, write it as a little function. When the question says write it for successive convolutions, well, build the fact in there that you're going to need a function that will need to take an input for how many times. Prepare yourself with an example, claim your authorship, and sort of get going that way. So now, as soon as you have something that basically vaguely works, you fix it. Clearly, this is the world's ugliest plot, and I'm not going to teach you how to plot X labels, Y labels, and titles on it, but you must do that, okay? The commands are X label, Y label, and title. Never, ever return a plot that doesn't have labels on it. Even if X is the independent variable and T is the PDF in question, that tells us more than just random things. So now you can and need to do a variety of things. One of them is to say, you know what? I am going to pick an x-axis for this thing because I'm illustrating the shape of this distribution. And so far I was just ranking it, and you see these x-axes keep going up. So how about I'll say, look, I know it's going to go to normal, or rather that's where I'm testing. So maybe I'll just make up a variable axis. And well, because I'm only going to plot potentially here. So if what goes from 1 to 0, I'm at my 1 convolution. So then I'm not getting a new one. So right here, I need to make a variable axis. And if I say, what is a reasonable x-axis to quote a standard normally distributed variable on that has an expectation of 0 and a variance of 1? What numbers would you pick? So it's going to look like this. And I'll want to make something reasonable for x. And so I don't, you know, I'm not being too specific here, but I'm saying, what x's do I pick for a mean 0 and a variance about 1? I mean, you know, the real answer needs to be negative infinity to plus infinity, but that's not going to happen.
So could you do -2 to 2, or is that just too small?
Tell me roughly where I would be, the sense of scale. -2 to 2, am I still going to see tails? Probably you will. We should verify that, right? But measured in standard deviations once, twice, 3 times, I'm not drawing it right here, but the mass under the normal between plus and minus 1, I'm going to take it back to MATLAB and try to compute it, okay? Norm CDF, that's the function, right? So I'm going to ask for what is the mass between -2 sigma and +2 sigma under the normal. That should be norm CDF to 2 for a 0, 1 minus norm CDF of -2 for the 0, 1. I can't switch back to my drawing now, but if I integrate from negative infinity to all the way down to 2, and I subtract from negative infinity all the way to -2, then I'm going to be left with the central portion. That's 95. -1 to 1, 68. -3 to 3, 99. So when people talk about 99th, you know, significance and so on, it's because under the normal, those are the canonical numbers: 68, 95, 99, 1, 2, 3 sigma. And when some software engineer working for an evil corporation tells you they're doing 6 sigma, it's like, we're always right, people. Okay, so that sets the sense of scale, and that's all I want to have for that, is that let's just make a variable axis that will show something that will not, that we're not cutting off too much. So I don't know, let me just try making an x that is between, I don't know, -4 to 4, then I'm going to have almost everything wherever I end up. So I propose you use the function linscale for a linearly scaled vector. And how many will you need? You will need the length of this, and then you can plot x versus that. Then I have just as many, and I've already decided what my axis is going to be. I'm going to try that. So I used linspace, and at the end I'll send you the thing, plus you can watch the recording. And I'll just do 1 convolution. Okay, so -2 to 2. 4 to 4, yep, it's on there. Oh, this is wrong. I must have made a mistake, and I will fix it.
Shouldn't linspace be after the for loop?
Yeah, oh no, I needed to copy it. I was going to begin with this one. They're right. I needed to have 1 because I might not have gotten 1. Thank you very much. Right, so I needed 1 in case I never entered the loop. And of course, I need 1 within every loop. So now I can do 23, and it always shows me, you know, where I'm ending. This is my device for saying I need to pick some x-axis, and I'm sticking to the same one for all of them. And I know that no matter where I end, I'm just going to have a sort of an appealing shape. But now I'm going to need to move to this normalization. So I'm telling you, this is not a PDF. I should begin by normalizing it. To normalize, of course, I need my x, because otherwise I can't integrate. So how about normalize the 0th moment? So I would say PDFF is going to be PDFF divided by whatever that integral is going to be, which I'm going to keep in brackets here. And of course, you know, successive convolutions, I got to do that there too. That's where in the homework I say, now you need to integrate something, and the smoother these functions become, and depending on how many numbers you have, you need to have some rule. And I should suggest that this one, that's mine. It's trap Z in MATLAB, okay? And so it's just an integral of a function numerically. So that to trapezoidally integrate this x over the PDFF is going to give me the integral under the curve. And assuming I'm not making a mistake, which I will find out by just running it, I'm now going to have y-axes that are normalized such that what you see on the screen is going to have areas of more or less 1 to, you know, the approximation of the integration. Okay? So now I've normalized it. Okay, well, I sort of started with this thing. I centered it to begin with. It's not leaving the center because that's what I made. I need to definitely do one more thing, and that's compare it with the Gaussian. I'm trying to get you an understanding for how fast this happens. You see, after 3 or 4, it's pretty Gaussian. I'm trying to get you ready for testing distributions. I'm trying to get you ready for if you're not picking uniform randoms or weirdly shaped distributions of any distribution or kind, that you're still going to get to Gaussian, but at a different rate. And you might want to explore what the rate is depending on the weirdness of your distribution or something that strikes your curiosity. So I'm going to need a second moment and the first moment. I cannot, and for the same reason that's what I opened with this question, I'm not generating any random numbers, so I don't use any of the random functions. And because I'm not generating numbers, I do not use the functions mean or variance because I have no numbers to take means or variances of. The expectation of this PDF and the variance of this PDF are only accessible by us taking moments of it. The first moment of the distribution how do I get the expectation of this PDF and the variance of this PDF by adjusting whatever happens here? Help me complete line 30, 31.
Over here, we need to find the first moment.
Let's do it. Oh, you know what? I can annotate my own screen, right? So this one is supposed to be, but of course it's only over the range, but we're getting close. This one needs to be the expectation of this PDF, which is what?
The first moment is x times px.
Okay, right. I'm going to need x times px, and here I'm going to need, if I'm going to call that x hat here, I'm going to need to call this squared, dx dx, right? Let that sink in for a second. Clear my drawings. How do I multiply the PDF by its argument? It's dot multiply. This is MATLAB. It's all discrete, and if you want to do an element by element multiply, it's dot times. And here, I'll be wanting a dot times a dot squared of an x minus ePDF. I'll be trying that. I may make mistakes because I'm typing, but let's go try it. Okay, so I do that. I copy, I paste. I end the plotting. I'll do a hold on. I'll plot the expectation. I'll repeat the expectation. Now I'm plotting a vertical line, same x between the y limits. And how about I plot between ePDF minus the square root of vPDF and ePDF plus the square root of vPDF. And where do I plot that? Let me do it right. Let me just say, I'll try to plot it at the maximum of the PDF divided by 2. I'm going to try this. We'll see if it works in a second. I just want to give myself a sense of scale. Vertical bar at the expectation, plot a horizontal bar at half height between plus and minus standard deviation, rather. All right. So now I'll clear F. I'll do it once for 1 to see if it kind of works. Okay, not too bad. 2, 3. I had hold on. I should have held hold on, but I'm not disliking the effect. Okay, 4, and so on. 44. You know, I held off. Okay, clear again. Help. Get my own test going. There is that. Maybe the half point is not well chosen because it actually doesn't touch. And if you want to do some simple math, find the height, find the value at which, you know, the standard deviation touches. It's not that far off, right? I need to just raise it a little bit. The y-lim is a function. And, you know, click on a panel, ask for y-lim, it gives you what the y-limit is. So I know that y-lim returns 2 numbers. And I know I want my expectation repeated, so I give 2 points that are vertical, and then that joins them up by a line. Similarly here, actually I would clean it up, and I would say I'm going to do ePDF plus -1 to 1 times the square root of the variance. And there, of course, I should be getting the same result. Here, I'm giving it again 2 x's, but they are different. And I'm giving it 2 y's, but they are the same. And again, I use a function called max to find whatever the maximum value of the function was, because I just need to peg it somewhere. I'm not implying anything. I'm not, my eye wants to see these things touch, but I don't want to spend the time to figure out exactly where that reaches that value. I just want to give a sense of scale. Okay, so have you proven to your, is this on the way to a proof that this looks Gaussian or not? And the answer is no. I want one more thing for sure. What can I do to convince you that it's nearly Gaussian? And first of all, I'll say maybe the need that is nearly Gaussian is if I went in 1, 2, 3, 5, and I'll do pi log 2, 23, is that as many numbers? Then clearly I start from some more exotic distributions. And you're like, well, is it tending to Gaussian? Yes, sir, but is it, right? So what can I do to convince you of how close I am to being Gaussian?
Also plot the normal plot in the
Yeah,
graph.
I agree. I think that's a good good thing to say, well, let's generate a normal with the same expectation and variance and see how alike they are. And then we can decide how to make them look good or bad. I told you that next week we're going to do more histograms, more formal tests and so on. Actually, we can't do the histogram now at all because we haven't generated any numbers. We cannot take any histogram of anything, right? We don't have a histogram. We have a function. We haven't sampled from it. We don't have any numbers. So let's generate a normal with the same expectation and variance. And well, norm PDF. What does it take? X mu sigma. So I'll say the comparative PDF, CPDF, is norm PDF. Where do I want it evaluated? I want it evaluated at the same X with the same expectation as just observed. I need this line twice right now. And then of the comparative normal. Plot X CPDF. I'll make it black. If you don't know MATLAB, you will know you can customize, of course, your line types and styles in myriad ways. Don't feel the need to play with it until you are understanding what the rest of it is. Let's do, 2. Okay, that's a little grainy.
Frederick, the BPDF is the variance, but you need the sigma. You need to square root it.
Yes, 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 very true. This is what I was going to say. I keep forgetting because sigma in statistics is the variance and sigma here is the standard deviation. And that's because sigma is usually big sigma with elements little sigma squared. So thank you for that here, right? Okay, and so now, at least now it's on the same level. It's as grainy as you go in, because if you're only doing 1, you're only getting a Gaussian at the point. If you're doing 10, of course, everything looks more smooth. So now you can invent for yourself measures of misfit. Does it look alike? Now is by eye. Do you want to subtract values in some squared and give them at least some sort of a relative score? That kind of does work. Do you want to do formal testing? Wait for later, because we normally never have this situation where we're never comparing. Now we're just comparing graphs of functions, but that's not the role of statistics, right? So you can be simple about this one. You cannot do a statistical test for any of this. We're just doing a graphical evaluation just to whet your appetite. I'll do my thing. So there's 4, okay. So now I still want to beautify a little bit. And actually, I just changed my mind. Instead of, wanting to switch back to normal, just continue on, because I think that'll help you furthest. How about we agree that I'm going to measure some sort of a function distance, invent some kind of reasonable distance to judge fit. And I'll say, well, I have my PDFF forever minus that comparative PDF which had the same expectation and variance and is a Gaussian. Of course, I have values only, so maybe I will just sum and square them. I mean, that's often our misfit, and that's practically what we're going to be doing from now on. And, it's often called phi, because I now like 4 letters, I'll call it P phi. P4. Okay. And now I'll do that. I really only need it at the end. I'm not writing the perfect function yet, but I could track how this evolves through the convolutions. It's going to be very useful. That's a measure of quality. Let me just try that. And then now title it with the sort of measure of Gaussianess. Okay, the real word is Gaussianity. The word title, how to get a number in a title. You need to print a number to a string, which is the argument to a title. That's called sprintf for some reason. And I'll call it phi. In fact, I could probably define phi and say big phi. I think that probably works. And now I might say, actually, let's do phi as the sum of the squared function value differences divided by the length of p phi. I'm doing an RMS error. And I want to print the symbol phi, I think that will work, and then the number p phi to a string, and I tell it what format I want this in. And, well, I don't know yet, so if I don't know it, I'll just go like, I don't know, 8 spaces, 6 behind the period, floating point. We'll try. Does not work. P phi, what am I missing? P phi.
Yeah, there.
I couldn't have used it or having it. Okay, that phi comes out excellently. It gets smaller, right? 001, 009, 0008, 006. Probably put some grids on. And then in the title, I should plot how many convolutions I've done. Otherwise, that's not useful, right? So that's going to be an integer, and n comes out. So n convolutions, comma, phi equals this number. Okay. Then I'm going to leave you with beautification, font sizes, title sizes, all that stuff. But I am now going to force you to use the print command, just because otherwise you may not get to it. Use only ever print, and you're using it, I recommend use it to the device PDF. And what better way to make a figure than to use the name of the function you've just written. That's already a pre-programmed function, m file name. So if I'm doing this right, and you see I'll just keep running it. At the end of this code, I have made myself a file called GEO422 HOW.pdf, which I can stick into my report. I'm going to sidestep the issue that you probably do want to crop it, because otherwise you get too much white space. Okay, so now let's do an output. And let the output be phi, some measure of Gaussianess. Okay, that you'd have to design. All you need to do to make that thing an output is to say, give it to me. And then you add it in your help, and then help shows it to you. So now if I say phi is, the first example was 1, right? That's going to be my, oops, it's p phi, obviously. Sorry. So I'll stick with, I need to call it exactly what I call it on the inside. Otherwise, why would it know it? When I call it, I can call it anything else, but when I define it, that needs to fit. Now I'll do format long to show you that it's 001, 007, that's right. And then the 2 became a 4, and that's 0006.462. And so I can have that. And now I'm really getting going, because actually I would say end with a plot only if you didn't request output. Or you can do that like this. If the number of arguments out is 0, then you're going to waste your time making this plot. Why do I do that? Because maybe I just want to quickly calculate this. I'm going to do one more thing and then I'll stop for questions. But you see, I said, all right, if I don't ask for an output, give me a plot. That gives me something to look at. But if I now just want to make a graph of this thing, and I'll say for index is 1 to 19, phi index is GEO2 index. Oops. One way of describing how well my functions converge, if you will, is by plotting them against the number of convolutions. So now I could plot 1 through 19 versus all them phis and see my rate. So that's one rate. I can mess with my functions here. I can go back to the 1, 1, 1. So that's that. I'm leaving this in. This is not the proper way of giving input, but I'm just doing it to show you that, fine, if I hold on, I do my experiment again, and I call it a fine. That's with the uniform. And I'll plot that. I expect this rate to be faster because I started from less challenging distributions, much faster. So from a single figure through a set of figures, through some sort of definitions of where you start and what you do with it, I want you to build a case that convinces you that successive convolutions of distributions tend to Gaussian behavior relatively quickly. And I want you to write this into a sort of a slightly more extensive set of tests and incorporate that into a document where you put these figures in there, captions, refer to them. If you've never used LaTeX, this is a very good time to do it. If you haven't used Overleaf, it makes it painless to start. And then later on, I'll tell you how to get out of it. But, you know, aim to write your homework with 1 or 2 functions modeled upon this. I'm going to send you this right away. Test it. Build yourself a case. You can see now, of course, that those 2 things here, they can be inputs, right? That's just my example. But if I get rid of these lines here, I could just, of course, make them extra inputs. I could do PDF1, which are the ones you want to convolve. You could build yourself an infinite way of specifying things that you want to test. And even if you don't want to write proper functions just yet and just play with it, you could take this as a model, and like I just did, you can change the distributions and see how it goes. Knowing that you're always, here's a successive convolution with the second one. Okay, please now let me know if there's anything else. You were free to interrupt me as we went, but if there, does this clarify sort of the burden of proof for you to convince yourself of the central limit theorem, at least mathematically? This is not statistically. This is just that the shape of these functions, you understand convolution, thereby you understand a little MATLAB, you understand a little misfit determination, and you can plot yourself graphics like this of exotic functions, of how close you get to a certain place, how trajectories differ if things get bad or worse, and things like that. Maybe I'll just leave by saying that for now, I want you to be able to do something along the lines that we've had. Make a computational argument, compute something, make a picture, report on it. If you want to use a clay tablet, be my guest. A Word document, save it as a PDF. LaTeX, great. Anything else that gets the thing, and then you put it all together in a single document and upload to Blackboard. A note on LaTeX, it's the best. You will never regret learning it. I'm going to keep it on my agenda to give you more of that. A note on Git. It's a version control software. Your Mac already has it. Your Windows machine will get it soon or easily. And there are sites built on it specifically for code exchange. GitHub.com is one of them. There is, this arrow is meant to connect both Git and LaTeX. And the site built on that is Overleaf. All these things have grown in the last few years. Initially, they were bad and hokey and serious people scoffed at them. Now, this actually worked pretty well. So our freshmen in the other class I teach, we put everyone on Overleaf on the first week, and they've, they're on their fourth little contribution. So if you are idle, read the introduction to LaTeX from Overleaf, register for your institutional account, try to do your first document, then you'll see you can get there. Same with GitHub. It's a good habit to get in for even dumb pieces of code like a homework. If you haven't ever done it, it's not the point. It's not required, not right now, but you will want to be finding out about it because it's really good for sharing and keeping track of your codes.